Deploying an ML model isn't the finish line, but the starting gun. In production, ML models demand constant care for sustained value and accurate predictions. Neglecting post-deployment health causes performance degradation, inaccurate insights, and costly business impacts. This video explores critical practices, monitoring, alerting, and retraining, essential for keeping your ML models healthy and optimal in dynamic environments. The real world is dynamic. Static models cannot anticipate changes. A model trained on historical data, however robust, eventually encounters new patterns or distributions. This performance erosion over time is an inevitable MLOps challenge. Understanding model degradation post-deployment is key to resilient systems. Primary culprits are two critical phenomena: data drift and concept drift. Data drift occurs when input data's statistical properties change. For instance, if a house price model's average income feature shifts, input data has drifted. Concept drift means the relationship between inputs and outputs changes. If buyer preferences fundamentally alter, perhaps valuing eco-friendliness over size, the underlying concept shifts. Both types directly impact model accuracy. Monitoring key performance metrics is paramount. For classification, use accuracy, precision, recall, F1 score. Regression models often use MSE or RMSE. Track these not just in aggregate, but segmented by features, user groups, or time to pinpoint degradation. Establishing a performance baseline with historical data is vital. Detecting data drift involves comparing current production data's distribution with training data's. Statistical tests like Kullback-Leibler or Jensen-Shannon divergence quantify differences. Monitoring descriptive statistics, mean, median, standard deviation, unique counts, for each feature also reveals shifts. Visualizing feature distributions over time via histograms provides insights. Identify input changes before performance drops. Concept drift is harder to detect directly. It doesn't always appear as input changes. Instead, model predictions become less accurate for the same inputs. Monitor model residuals. Consistent error patterns might indicate a concept shift. Comparing predictions with actual outcomes, when ground truth is available, is crucial. A/B testing new model versions can also reveal concept drift. When performance degradation or drift is detected, timely intervention is critical. Robust alerting systems are essential. An effective system automatically notifies stakeholders when predefined thresholds are breached. For instance, if classification accuracy drops below a set percentage, or a data drift test exceeds significance, an alert triggers. These systems transform passive monitoring into actionable insights. An alerting system typically involves several components. First, define clear thresholds for each monitored metric or drift detection method. Calibrate these carefully to balance sensitivity and avoid false positives. Second, establish notification channels, email, Slack, or dashboards. Third, implement escalation policies, ensuring unaddressed alerts are prioritized. The goal: informing the right people about the right problem at the right time. When monitoring reveals significant drift or a performance dip, model retraining becomes necessary. Retraining updates the model using newer, more representative data reflecting current reality. There are two main approaches: automated and triggered. Choice depends on model criticality, data change rate, and cost. Retraining isn't just about new data, it's an opportunity to reevaluate features, algorithms, and hyperparameters. Automated retraining pipelines suit models in dynamic environments where data and concepts change frequently. These pipelines can run at regular intervals, daily or weekly, or be event-driven. An event-driven approach triggers retraining automatically when an alerting system detects persistent data drift or a sustained performance drop beyond a threshold. This ensures continuous model adaptation with minimal oversight. Triggered retraining involves explicit human intervention or an external event. This could be a manual decision by a data scientist after reviewing reports, or triggered by significant business events, a product launch, market shift, or regulatory change impacting data. Less frequent, triggered retraining allows a more controlled, thoughtful approach, often involving deeper analysis of degradation causes. Retraining is not a magic bullet. Several considerations exist. Data versioning tracks which data was used for each model, ensuring reproducibility. Model versioning allows seamless deployment and rollback if a new model performs worse. Rigorous validation of the retrained model is essential before production deployment. Computational costs and potential regressions must be weighed. While automation is powerful, a human-in-the-loop approach remains vital for complex, high-stakes ML systems. Human oversight catches subtle anomalies automated systems might miss, interprets ambiguous alerts, and makes strategic decisions about updates, especially when retraining results are unclear. Data scientists and domain experts should periodically review performance and participate in the improvement cycle. Maintaining ML model health post-deployment is fundamental for sustaining business value. By implementing robust monitoring, clear alerting mechanisms, and intelligent retraining strategies, organizations ensure ML models remain accurate, reliable, and relevant in ever-changing real-world environments. This proactive MLOps approach transforms deployed models into dynamic, continuously learning assets, driving better decisions and outcomes.